सो हाय गाइस, आज मैं ये लैब करने वाला हूँ ट्रैवल शूटिंग एंड सॉल्विंग डाटा जॉइन पिटफॉल। तो बेसिकली joining data tables can provide meaningful insight into your data set. However, when you join your data, there are common pitfalls that could corrupt your result. So this lab focuses on avoiding those pitfalls. Okay, तो अब join के बारे में आपको पता है, there are multiple types of join: cross join, inner join, left join, right join, self join. So what you will do in this lab: use BigQuery to explore and troubleshoot duplicate rows in a dataset, create joins between data tables, choose between different join types. ओके, तो सेटअप कर लेता हूँ पहले, उसके बाद आपको स्टार्ट करता हूँ टास्क। ठीक है, सो मैंने बिग लॉगिन कर लिया। अब BigQuery में जाता हूँ, स्टूडियो खोलने दो इसको। हम जाते हैं टास्क 1 में। क्रिएट ए न्यू डेटा सेट टू स्टोर योर टेबल्स। तो डेटा सेट हम लोग किस लिए क्रिएट करता है? टू स्टोर टेबल्स। इधर से आपको समझ आ गया होगा ना। तो ई कॉमर्स डेटा सेट को फिर से क्रिएट करते हैं। फिर से मतलब क्रिएट, जस्ट अभी क्रिएट करते हैं, एक बार क्रिएट नहीं किया अभी इस लैब में, तो करते हैं। बाकी सबको बाय डिफ़ॉल्ट ही रहने देते हैं। तो डेटा सेट क्रिएट हो चुका है। ग्रीन टिक हो गया है। टास्क 2: प्रिंट द लैब प्रोजेक्ट इन बिग क्वेरी। योर टीम प्रोवाइड्स यू विथ ए न्यू डेटा सेट on the inventory stock labels for each of your products for sale on your e-commerce website. You want to become familiar with the products on the website and the fields you could use to potentially join on to other data sets. The project with a new data set is data to inside query. Add. कहा दिख नहीं रहा मेरे को। द वेलकम टू बी query in the Cloud Console message box opens. BigQuery public datasets are not displayed by the default. To open the public dataset project, copy data to inside. Click plus add star a project by name. सो गाइस मेरे को पता चल गया है। आपको अभी इधर ऐड में जाना था, फिर आपको स्टार ए प्रोजेक्ट बाय नेम में करना था, फिर इधर डाटा टू इनसाइड में करना है और उसके बाद स्टार देना है। ठीक है, उसके बाद ये सब देख सकते हो आप लोग। जो जो डेटा सेट है, ये प्रोजेक्ट आईडी है ना। तो and star then star, okay, then data source list in the explorer section, data to inside, okay. Task 3, examine the fields. Get familiar with the products and field on the website you can use to create queries to analyze the data set. In the left pan in the resources section, navigate to data to inside e-commerce all season new. E-commerce data set, then all season new or raw, all season raw, I think. No? All season raw, sorry. Yeah. On the right under the query editor, click the schema tab to see the fields and information about each field. Okay, full visitor ID, channel grouping, these are the column names, right? Okay, देख लिया. Task 4, identify a key field in your e-commerce dataset. Examine the products and field further. You want to become familiar with the products on the website and the fields you could use to potentially join on to other datasets. Examine the records. In the section, you find how product names and product SKUs are on your website, whether either one of those fields is unique. Find how many product names and product SKUs are on the website. Copy and paste the below query. Product SKU to product name. SKU and below query, right? That's right. It's product SKU and B2 product name. 2273. How many rows of product data are written? 2273. But do the results means that there are that many unique product SKUs? One of the first queries you will run as a data analyst is looking at the uniqueness of your data values. Clear the previous query and run below query to list the number of distinct SKUs are listed using distinct. ओके, इधर दिखा रहा था 2273। देखते हैं अब इधर 1909, that's mean there are duplicate SKUs. How many distinct SKUs are written? 1909, I think, right? Yes, 1909. There are fewer distinct SKUs than the SKU and product names query had before. Why do you think that is? The first query was excluding some product names. The first query showed that only one product name can belong to a SKU. The first query also return product name. It appears multiple product names can have the same SKUs. Correct. This one is correct. That's why it is showing more number of rows in the first query, right? Because there are the multiple can have product names can have the same SKU. Examine the relationship between SKU and name. Now determine which product have more than one SKU and which SKU have more than one product name. Clear the previous query and run the below query to determine if some product names have more than one SKU. The use of string aggregate function to aggregate all the product SKU that are associated with one product name into comma separated values. Okay, see in this query what it is trying to do, it is selecting product name and count of distinct product SKUs as SKU count, string aggregate, distinct product SKU, limit 5 as SKU. Where product SKU is not null, group by is v2 product to name, having SKU getter count greater than 1, एक से ज़्यादा हो तभी हाँ, order by SKU count descending. रन करते हैं, देखते हैं. तो इस प्रोडक्ट का जो प्रोडक्ट नेम का है इसका 12 SKU काउंट है और क्या क्या है इधर आप देख सकते हो 12, मतलब 5 देख सकते हो ना, 5 इसने रखा होगा, लिमिट 5 रखा है ना इसलिए. So do some product names have more than one SKU? Look at the query result to confirm yes. So which product has most SKUs associated? Hmm, order by SKU count, right? Descending, yes. Wage women, wage women's typography, something. The e-commerce website catalog shows that each product name may have multiple option. Each product name may have multiple option like size, color, which are sold as separate SKUs. Okay, okay. So you have been seen that one product can have 12 SKUs. What about one SKU? Should it be allowed to belong to more than one product? क्या बोल रहा है? So you have seen that one product can have 12 SKUs. What about one SKU? Should it be allowed to belong to more than one product? Let's see. इधर जो हम लोग फाइंड करने की कोशिश कर रहे हैं प्रोडक्ट एसक्यू दिखाएगा. उसके बाद उसका जो प्रोडक्ट नेम है कितना मतलब है, मतलब वो एसक्यू के लिए कितना प्रोडक्ट असाइंड है देख सकते हैं. ओके. सो एक प्रोडक्ट एसक्यू का भी 3 प्रोडक्ट नेम है. कैसे? Try replacing string aggregate with array aggregate instead. Pretty cool, right? Okay, let's see. Mhm. Oh, It's good, but I think string aggregate is better, like in representation, right? See, okay. Waterproof gear bag, waterproof gear bag, Google small waterproof towel. When you look at the query result, are there single SKUs values with more than one product name associated, right? What do you notice about those product names? Yes, most of the product names are similar but not exactly the same. You will see why this many to many data relationship will be an issue in the next section. Identify a key field in your e-commerce dataset. Pitfall, non-unique key. In inventory tracking, a SKU is designed to uniquely identify one and only one product, right? For us, it will be the basis of your join condition when you look up information from other tables. Having a non-unique key can cause serious data issues, as you will see. So write a query to identify all the product names for the SKU this. Okay. So where the product SKU this, let's see the product names. Mhm. What do you notice about the product names? They are exactly same. They are mostly the same except for a few characters. From the query result, it looks like there are three different names for the same product. In this example, there is a special character in one name and a slightly different name for another. Joining website data against your product inventory list. Now see the impact of joining on a data set with multiple products for a single SKU. First, explore the product inventory data sets, the products table to see if the SKU is unique there. Clear the previous query and run the below query. Okay, I can see there are only one unique SKU, right, for one product. Is the SKU unique in the product inventory dataset? Yes, just one record is returned. Correct. How many drop frisbee do you have in inventory? Inventory 154 something. 154. Stock level is 154, right? Yes. So join pitfall. Unintentional many to one SKU relationship. You now have two dataset, one for inventory stock level and the other for our website analytics. Join the inventory dataset against your website product names and SKUs so you can have the inventory stock level associated with each product for sale on the website. Clear the previous query and run the below query. Okay. See, in this website for one SKU, this SKU there are uh, multiple product, right? Multiple product name. But for inventory there are one. So when we are joining, inner joining with the product SKU and inventory SKU, so what it will happen? Let's see what it is showing. See, this is wrong information, right? For this product SKU, there is a one product name in inventory, and the stock levels is 150, 150, 154. But here it is showing when we are joining for this product, the different product, but in logically it is one product. But when it is showing it three product, and for these three product there are stock level 154, 154. So it is wrong, right? What happens when you join the website table and the product inventory table one SKU? Do you now have inventory stock level for the product? No, there is no inventory data. The join did not work. The join did not work. Yes, there are inventory data and everything looks fine. Yes, there are inventory levels, but the stock level is showing three times, one for each record. Next, expand our previous query to simply sum the inventory available by product. Okay, it is showing 462 total inventory, but that is wrong. Is the dog frisbee properly showing a stock level of 154? Yes, it is at 150. No, it is now at 462 showing three times one for each record. Oh no, it is 154 into 3 is equal to 462 or triple counting the inventory. This is called an unintentional cross join. A topic that will be revisited later. Okay. Task 6. Join pitfall solution. Use distinct SKU before joining. What are the options to solve your triple counting dilemma? First, you need to only select distinct SKUs from the website before joining on other dataset. You know there can be more than one product name, like 7, dog frisbee, that can share a single SKU. Gather all possible names into an array. Okay, array aggregate, right? Product SKU, and then there will be single product SKU and there are three names. Okay. Now instead of having a row for every product name, you only have a row for each unique SKU. If you wanted to duplicate the product name, if you wanted to deduplicate the product names, you could even limit the array like so. Join pitfall losing data record after join. Now you are ready to join against your product inventory dataset again. Okay, no, it's just 2090. How many records are written? One, no, just one, right? Yes. So it seems 819 SQs were lost after joining the dataset. Investing by adding more specify in your field. One SQ column for each dataset. Clear the previous query and run this query. These two SQ are available in these two tables, right? So which SQs are lost? It appears that SQs are present in both of these dataset after the join for these 1090 records. How can you find the missing record? We have to do right join and where it's not right. Yes. The default join type is inner join, which returns records only if there is a SQ match on both the left and right tables are joined. Rewrite the previous query to use a different join type. Okay. If we do left join, it will return all the record from the left table. Still 109 correct. 1909. Yeah, you have successfully used a left join to return all of the original 1909 website SQs in your result. True. Many inventory SQ values are null. Yes, true. How many SQ are missing from your product inventory set? Write a query to filter on null value on the inventory table. 819. How many product are missing? 819 product are missing. Like SQ is null from your product inventory data set. Clear the previous query and run the below query to confirm using one of the specific SQs from the website dataset. There is no okay. Why might this product inventory dataset be missing SQs? Some SQs could be digital product that you do not store in your warehouse inventory. Old products you sold in past websites. Orders are no longer offered in current inventory. There is a legitimate missing data from inventory and should be tracked. All of the, I think all of this, all of the above. So no, no, no. Some SQs could be digital products. It is not also. Then it is cut. I think some SQs could be digital product that you do not store in warehouse inventory. Okay. Now, what about the reverse situation? Are there any product in the product inventory data set but missing from website? Write a query using a different join type to investigate. Right join? Yes, that is true. Yes, there are two product SKUs are missing from the website dataset. Next, add more fields from the product inventory dataset for more details. Clear the previous query and run the below query. Okay. Select distinct website product SKU. Mm, Okay. Possible answer. Only new product, no order, no sentiment score, and one product is that is in store only. Why would the new product not showed up on your website dataset? The website dataset is past order transaction by customer brand new products which have never been sold on showed up in web analytics, right? Until they are viewed or purchased. You typically will not see right joins in production queries. You would simply just do a left join and switch the ordering of the tables. What if you wanted one query that listed all products missing from either the website or inventory? Write a query using a different join type. Full join and where this is null and this is null. Full join where product SKU is null or otherwise it is null. Total 820, right? 819 from this side. Side. Correct. Left join, right join is equal to full join, which returns all record from both tables, regardless of matching join keys. The- okay, okay, okay. You then filter out where you have mismatches on the other side. Join pitfall. Unintentional cross join. Not knowing the relationship between data tables keys like one and can return unexpected result and also significantly reduce query performance. The last join type is the cross join. Create a new table with a side-wide discount percent that you want applied across products in the clearance category. Clear the previous query and run the below query. Okay. So I'm going to create a table, site-wide promotion, and select 0.05 as discount. Okay. Mm, mm, discount and value will be 0.5. 0.05. How many product are in clearance? Cross join. To cross join with every record, right? Discount every. How many product are on clearance? 82. For a cross join, you will notice there is no join condition. This field is simply multiplied against the first order dataset or zero point zero 0.05 discount across all items. See the impact of unintentionally adding more than one record in the discount table. So clear the previous query and run the below query to insert two more record into the promotion table. Next, view the data in the promotion table. Select history. 3. What happens when you apply discount again across all 82 clearance products? Product SKU, product category, discount as website, cross chains, one product light clearance, like clearance, right? 246 for every SKU it is multiplied, right? Instead of 82, you now have 246 returns, which is more record than your original table started with. Now investigate the underlying cause by examining one product SKU, clear the previous query on the following. There are three product SKU. Since there are three discount codes to cross join in, you are multiplying the original data set by 3. The solution is to know your data relationships before you join and don't assume keys are unique. Okay, I will know. I will remember that. Congratulations, you have concluded this lab and walked through some serious skill. Okay, so I have completed this lab and now I'm going to stop it.